Hello friends, so very warm welcome. This is Ishan on behalf of Edureka. So it's been a pretty good journey that we have been doing these sessions. So I'm gonna take on to something known as Spring Framework for the day, and I hope you will enjoy the session. So let's just start. So what's the agenda for the day? So guys, we're gonna understand the Java frameworks for the day, right? And thereafter we'll jump on to Spring Framework and we'll understand why we need Spring Framework and what exactly it is. Thereafter we'll also understand the architectural part of Spring Framework, and we'll try to discuss few modules available in the Spring Framework. We'll also see what and all are the various features associated with the Spring Framework, and we'll try to do one code on Spring Framework. So let's start with the Java framework. So what exactly are the Java frameworks for us? So guys, we know what exactly is Java, right? So it's a programming language which is supposed to help us solve a particular problem, right? And frameworks are nothing but they are the predefined APIs which we can embed in our programs, right? So let's see. So when as a developer we are writing, so we need to write a lot of code, and many a times when the projects are in a deadline, so we are dependent on libraries to accomplish our projects in time, right? So these libraries are nothing but they are the frameworks or they are the APIs, right? So as a developer you shouldn't be bothered about writing a lot of code. So as of now you can see, right, so much of code. So as a developer we are pretty much tense about it. So need something that is fast and efficient. Now that's where we're gonna talk of Java frameworks, or we're gonna talk of the APIs, that's like application programming interfaces, which we need to put into our programs. So here's the solution. So I can use Java framework, and using the Java frameworks, it's gonna be very easy for us to achieve our targets and our deadlines in time, right? So this fits with my code too, right? And whatever the frameworks you're gonna choose. So we got a lot of frameworks, lot of APIs available in Java now. So as per our requirement, we need to choose. For example, let's say that I want to search in PDF, or I want to generate an Excel report. So I need not to write a Java IO API. So I need not to write my own Java IO code. So I can use the predefined libraries, right? So like iText or like PDF, available libraries, and I can do my task very easily. So the problem is solved, right? Whenever you start using the frameworks, or when you start using the predefined code snippets in your programs. Now, what's the key benefit of having all these things, right? So my application speed and efficiency is also increased because the frameworks or the APIs, they are written in such a way that they are very well optimized. So we are looking on to a point now, right? So we started from a confused state, and we have reached to our potential state where we have to meet our project deadlines and all, right? So guys, the key target should be to use the frameworks as much as it is feasible and it is possible in our programming structures, right? You shouldn't be writing the code from the scratch. So in a smart world, if we are writing the programs from the scratch, right, it's not gonna help us, right? So always try to rely on the frameworks as possible as. All right, so Java frameworks principle, what exactly the Java framework principle is all about, right? So it abides the Hollywood principle, that is don't call us, we will call you. So it's basically inversion of control which we are talking about. So what exactly this key principle states like, so we got some class, right, for which we will create the object traditionally. So what is happening over here? So you create a class, you write down a class, and then you create an object. But we are trying to talk of inversion of control, which says that do not worry about creating the object. So framework's gonna create objects for you. You just configure the objects now, right? So let's say if we have a class A which is having a dependency on some other classes like B and C, right? Or you can say it is the other way around, right? So if B and C are dependent on A, or A is dependent on B and C. So how we can solve such problems? So Spring Framework is one of the key framework, right, which focuses on inversion of control with the key principle as a dependency injection, right? So that's what we're gonna discuss. So the traditional way of constructing the Java object is by the developer, but the Java framework principle or the Spring framework principle will state that you don't worry about constructing the object. Objects will be constructed by the frameworks itself. All right, so let's see various different Java frameworks available in the market. So guys, we have a lot of frameworks available in the market, right? To name a few, so Hibernate, Struts, and Spring, these are quite famous frameworks available in the market. So JSF, Play, Maven, we got a lot of frameworks now, right? These are some of the most importantly and widely used frameworks in the industry. So we are typically going to focus on Spring framework. So let's see that. So what is Spring Framework and what exactly are its key features? So let's now switch on to that. So guys, Spring has been available on SourceForge and it's available since January 2003. So it's basically an open source project and it was introduced by the guy Rod Johnson, if you can see this guy, right? So the first version was released in the February 2003 and so till that, right, so Spring is available as an open source community. You can always browse the spring.org and you can browse its APIs, you can browse its documentation and you can learn a lot. So over the passage of years, right, so we got 4.3 as in the latest version in 2016, right? So this is widely used version in the Spring framework. Let's now understand the definition of the Spring framework. So Spring is one complete and a modular framework for developing the enterprise applications in Java, right? So guys, when we talk of Spring as a framework, right, it's a Java framework, but it is an enterprise edition Java framework. So what is meant by this term enterprise edition, right? So whenever we are writing the applications for the enterprises, let's take an example of an enterprise. So Amazon is an enterprise now, right? Google is an enterprise. So when we are supposed to solve the problems associated with the enterprises, we use the Spring framework. All right. So Spring framework can be used for all the layer implementations for a real-time application, right? So when I'm talking about the layer, so let's try to keep it very simple. Let's say model view controller architecture, right? So we got a Spring MVC as a design pattern which you can use to completely construct all the layers in your application. So Spring can be used for the development of particular layer as well. So if you are not interested in writing all the code in your Spring framework, you can also write few of the layer codes. Let's see some features associated with the Spring framework. The first thing it is open source, right? So it means that you can anytime have an access to the code and you can manipulate it and you can use it as in your own domain, right? So let's say I want to write a hospital management system on an enterprise level, right? And I need to use the Spring framework. So I can manipulate the framework and I can try to manipulate the APIs which fits into my key domain itself. So we got comprehensive tools available in our Spring framework, right? It's lightweight when we talk of the memory part, right? So it's very much relevant in solving the problems because it follows the design patterns and it effectively solves all the problems which we face in our enterprise edition of Java. So we typically say that Spring framework is basically a framework of frameworks. Now why framework of frameworks? Because you can use a lot of frameworks within the Spring framework itself. For an instance, if you want to do object relationship mapping using Hibernate, so Hibernate can be integrated or it is already there. It's already there. So we got the APIs through which we can directly access Hibernate, right? So that's why we say it's basically framework of frameworks. So it avails array of resources. So we got a lot of resources starting from the very scratch. Let's say I want to implement security in my application or I want to implement something known as a model view controller or any other thing, guys, right? So it's basically an array of resources. So you can avail a lot of features within the Spring framework itself. Even the support like unit testing is also available in the Spring framework itself. All right, so why we need to use Spring framework? I think the previous discussed features, they are quite relevant that why we should be using Spring framework, but let's try to understand it in more detail. So guys, these are the relevant usages across the industry, right? So we got different frameworks available in the market, but if you can see the Spring MVC, so it's outshining all the other frameworks in the market industrially, right? So it means that it is industrially adopted and it is quite, robust, and all the industry, all the companies, they love development in Spring framework and it is really popular. Now there are reasons that why it is so popular. So it's simple now. So if you talk of the simplicity level, so there are three basically main reasons out here now. The simplicity is the first level, right? The writing of code is very easy in the Spring framework, right? Because here you are trying to configure the things and you are not trying to write the major portion of your code. You're trying to configure the things. Then we got testability, right, and loose coupling. So these are some of the other key concerns, and let's now discuss them one by one. So when I talk of simplicity, so here you are always focused on writing your business objects, as in POJO or model or beans, right? So what is POJO? POJO is plain old Java object. So you are supposed to write your Java object definition in the form of class in your programs, right? So it's POJO or POJI. So when I'm talking about plain old Java object, in a similar way we got interfaces now, right? So you can also write interfaces which will help us to get to our definitions to be implemented by us. Then we got something known as testability. So Spring Framework is already having the testing layers available. For example, we got JUnit already integrated. So you can always perform a unit test or an integration test as per your requirement, right? So this is something where we can write our own test cases and we can test our own code, right? So this is one also great feature which is available in the Spring Framework. Then we got loose coupling. So here we are trying to understand that Spring objects are loosely coupled. Now for this, first of all, we must understand what is meant by the term coupling and what is this loose coupling all about, right? So consider that you got a class rider, right? And we got a bike. So this bike over here, the reference to the bike object is basically initialized in the set bike method, right? So we got this interface bike available and we have a start method. So we got various classes like Honda, Bajaj or Yamaha, right? So which can implement the interface bike and they will have a method like start now, right? And we can anytime at runtime set the bike to either be Honda or Bajaj or Yamaha. So runtime polymorphic concept over here is implemented in a very beautiful way, and it ultimately takes us to something known as loosely coupled environment. So let's try to discuss this as one example that how loosely coupled concept comes into action. Let's say I got one class as in rider, correct, and we got one more class as in bike. Now if rider has a reference to bike and I am going to create one constructor for the rider where I am going to create an object of bike, right? So object of bike is constructed when object of rider shall be constructed. Now that is the true reality over here. So if I'm trying to say that, I will come up in the main. So if I'm trying to create the object of rider over here, so when I am creating the object of rider as of now, so the moment the rider constructor will be executed, your bike object will be constructed. It means that there exists a dependency of your bike object construction on the rider object construction, right? So this is like high in coupling. So we got high coupling over here. Now I need to reduce it. In order to reduce it, what I will do, I will just come down and I will create one function like set bike and I will write the reference over here in this fashion, right? So I'm going to say this dot be assigned b. So it means that now you don't do the concept out here. So rather than you create the object over here in the main, now the construction of bike object is not dependent on the constructor of the rider, right? So that's one key concern over here. So what I will do, I will just say r dot set the bike to be b, right? So this is where we are trying to reduce coupling, right? And I will say that it is low coupling. So guys, this is where we will be reducing the coupling. So when I am talking of the Spring Framework, so Spring Framework will focus on always writing the code so that it is loosely coupled, right? So loose coupling concept with the runtime polymorphism, it brings a charm in your code as in design pattern. So what exactly is the ecosystem of the Spring Framework? So guys, we got a web layer, right? And we got a common layer, service layer, and a data layer. So these are the different layers available in the Spring Framework ecosystem. So we got the web layer, right? And it's basically the Spring IO platform, right? And thereafter we got a common layer where we do some basic operation as in Spring Boot, right? And thereafter we got service layers and the data layers available, right? As in the Spring XT and the other components available in the Spring Framework, right? So this is like the entire Spring Framework ecosystem, how the Spring framework's gonna come up and interact, and it is available in various modules available. So let's see the architectural part of the Spring framework. So guys, in the architectural part of the Spring framework, we got the base layer as the testing layer available, right? So it's a layered architecture now. So Spring architecture is a layered architecture. So the testing layer is basically focusing on the JUnit part, right? So where we can write the unit testing. Then we got the core container. So core container of the Spring framework includes beans, core, context, and Spring expression language. So this is the major and the main layer of your Spring framework, right? So here we got inversion of control and dependency injection, which is used in the upper layers evenly, right? And this forms the core part of your Spring framework. So on top of core container, we got AOP, aspects, instrumentation, and messaging. So AOP is basically aspect oriented programming. So with the aspect oriented programming, we try to focus on cross-cutting concerns. So what is meant by this term cross-cutting concern? Cross-cutting concern is a concern which is a kind of a security now. So security has to be taken care in all the modules whenever you are writing the project, right? So aspect-oriented programming helps us in implementing the cross-cutting concerns now. Thereafter, we got data access integration layer, with the help of which we will be able to access our databases, right? Or you can say where we got our data sets available. We got a web container over here where we can write the Spring MVC web application, right? So we can have servlets, then portlets, which are the standalone applications over the web interfaces itself. So let's see the modules. So the Spring module, basically it contains a lot of features and they are quite well organized, and we got somewhere around 20 modules available, right? So the modules are grouped up and they are based on their few of the features as in the following, right? So as in the layered architecture we discussed, so in a similar way we got these frameworks available. So we got core container, data access or integration, right? So you can access the data sets, or you can have integrations with the frameworks like Hibernate or so. So core container will be the one which is the basic functionality. So using the web layer or the web APIs, we can write the web MVC code. Then aspect oriented programming, the way we got object oriented programming, in a similar way we got aspect oriented programming. So here we are trying to fulfill the cross-cutting concerns. Then we got instrumentation and the testing layers. Let's talk about the modules one by one. So when we are talking about the core part of the Spring framework, so we got a core container which focuses on dependency injection and inversion of control. So the core layer provides the fundamental parts for the framework. So these are the base of the Spring framework now, right? So we got something known as beans, context, and Spring expression language. So these are the three important key concerns, right? So guys, beans are nothing but they are the Java objects which are constructed by the Spring framework. So you need to configure them. Then we got context. It's an implementation of the beans itself, right? So it supports internationalization, for example, EJB, JMS, or remote APIs if you want to come up with that. Then Spring expression language is an expression language with the help of which we can write programs even. The data access modules of the Spring framework will be able to access the data sets, right? So if you have the data available in the database, let's talk about, we got an Oracle as a database, right? And we need to interact with the Oracle, and we can do so very easily with the Spring framework. So we got a JDBC layer, we got ORM layer. So that's like, these are all integration layers. So ORM is like object relationship mapping, for example, the Hibernate. So we got these integration layers which we can use. Then we got basically an object to XML mappings available. Then Java messaging services are available. Then transaction management is also available, right? So if you are going to fire a transaction, so commit and rollback, all these supports are available within your data access module itself. So guys, over the web layer, we are trying to understand something known as a model view controller based web application, right? So the main industrial usage over the web is web MVC module, right? So that's like one of the major modules which is quite readily used in the Spring framework, and it is industrially accepted. So we got something known as web oriented features, right? We got portlets and sockets. So portlets are nothing but they are the standalone applications which are running in a web application, right? And thereafter we got web sockets in order to come up with a two-way communication. So the few miscellaneous modules which are available in the Spring framework includes AOP, right? So AOP is where you are going to fulfill the cross-cutting concerns. Then we got instrumenting, where we provide the class instrumentation support and class loader implementation. We got aspects, right? So aspects are nothing but it provides the integrations with the aspect J, and aspect J is something where we're gonna fulfill the cross-cutting concerns exactly where. Then we got messages, right, and the testing layer. So guys, in case you want to come up with the unit testing, so we got support with the help of components like JUnit or TestNG. So these are again the frameworks. So that's why we call Spring Framework as a framework of frameworks. Now let us understand how the Spring Framework will flow. So guys, the very first component in the Spring Framework is inversion of control, right? So we need to come up slowly and slowly so that we can reach up to the endpoint. So the first component is inversion of control. Let's see that. So what exactly is the inversion of control? So traditionally when we are writing the program, so we will create the object, right? So that's like you come up and you create the object. So once the object is constructed, right? So we need to wire them together. So let's say we got multiple objects now and they have a dependency in between. Let's take our previous example as in bike and rider example, right? So rider will have a bike. So now we need to fulfill this dependency somehow. So we need to configure them. In Spring Framework, what we do, we configure them, and thereafter, so whole management of the life cycle of the objects is taken care by the Spring Framework itself. So we don't worry on that part. So guys, we'll try to code this flow and understand that how this flow will exactly work. All right. So what and all are the other concerns related with the IOC container? So guys, the Spring IOC container, by using the Java Pojo classes and configuration metadata, produces a fully configured and an executable system or an application, right? So what we are trying to say is that you come up with the Pojo class, you write the Pojo class, and you provide the metadata in the form of some XML configuration. You give it to the Spring Framework or the Spring container, and it will automatically give us the objects which we can use directly in our application, or you can say we got a ready to use application itself. So let's see what exactly are the IOC containers. So we got two different APIs which are the IOC containers in the Spring Framework. One is the Bean Factory, other one is the application context. So Bean Factory is basically an interface, and application context is an implementation of Bean Factory itself. So it is always better to come up and use application context. So what happens over here, these containers will basically load the XML files, and thereafter they're gonna construct the objects for us. So we can also do by writing the annotations in our Pojo classes itself. If you want to skip XML, you can come up with the annotational model. So that is also supported. Now, after the inversion of control, we got dependency injection. Now, dependency injection is all about when we have dependency in our code, right? So Spring Framework has this DI technique where we can remove the dependency from our code, right? So it's gonna make our application quite easy and managed to use, and most importantly, our programming code becomes loosely coupled, right? So that's the key important point which we need to take care even when we are writing the code examples. All right. So how this dependency injection is taken care by the Spring Framework? So in the Spring Framework, we got by constructor and by setter method. So these are the two different techniques, right, by which the dependency injection is resolved, right? So we got a constructor arg and a property as key tags, which can help us to resolve this dependency injection. Then next is the AOP, that's like aspect oriented programming. So aspect oriented programming is basically where we need to implement cross-cutting concerns, right? So I'll just try to take up one example of a cross-cutting concern, right? So consider that we logged on to Amazon and we want to look on to a product, right? So I search for an iPhone. So the moment I started searching the iPhone and I'm browsing the different iPhones in the same category, that's like Apple iPhone. So Amazon will record from what time I started surfing the iPhones and what time I left surfing the iPhone. So based on that, Amazon can give me some promotional offers, or I can get some, emails, or I can get some advertisements from the Amazon, which will say that you must purchase this iPhone, right? So logging. Now logging is also a kind of a cross-cutting concern. To implement such cross-cutting concerns, we can use aspect-oriented programming in the Spring Framework. So it gives us a lot of other things, right? So as in the number one, it's going to provide the modularity. Then AOP will break the program into the distinct parts called concerns. It also increases the modularity, right? When we write these cross-cutting concerns, and a cross-cutting concern is a concern which can affect the entire application, right? For example, security is one of the major cross-cutting concerns, right? So we must be implementing them in a proper and in a regular way. All right, so have a look, guys. So in a cross-cutting concern, so if we have a different modules, and if we got couple of layers, for example, model, view, and controller. So we need to implement these cross-cutting concerns in every module and in every stage, right? Let's say security. So if I'm writing a very basic code and I'm trying to come up with the last level of my code, I need to make sure and I need to ensure that security always remains. So the last component or the last important concern which we have to discuss over here is a model, view, controller, as in the Spring framework, right? So guys, what happens over here when we are writing any enterprise application or a web application, or if you try to write any software product, right? So model, view, controller is one design pattern. So in this design pattern, what happens, the user will send a request over the presentation layer, right? So this request can be onto a presentation layer, that's like a user interface. So it is typically a view, right? So request will go from the view to the controller, and controller is that guy which will process the request from the client or from the user, right? So typically the client over here is acting as a browser now, correct? So let us try to understand. If I'm going to search an iPhone in the Amazon, right? So when the Amazon website is open, it's the presentation layer, we call it a view. When I'm searching the iPhone and when I click on the search, so this request goes to a controller which will process from the data set. So model represents the data set over here, right? So we'll get the data from the data set into the controller, right? And controller can give it back to the view, and this can be sent back as a response to the user. So model, view, controller as a design pattern. So what we need to focus, we need to write the model separately, controller separately, and view separately. So Spring MVC as a complete one package helps us to write minimal of code, because it's all modeled as a framework itself for us, right? So you need to write minimal code, and you just need to write your own business logics, and everything else will be taken care by the Spring MVC flow. All right. So let's summarize the entire part. So guys, we got Java frameworks, we got Spring framework, why Spring frameworks, the architectural part of the Spring frameworks, what are various modules available in the Spring framework, and few of the Spring features which we have discussed, right? So now let's try to come down and see one snippet over the Spring framework, right? So I'm going to write one Java application. So let's try to write one Java application, and let's see how we can come up with our Spring framework example. So let's say it's one Spring Edureka demo, and I'm gonna finish the project. So here we are with the Spring Edureka demo. Now what I'm going to do over here is I'm going to write one new class, and I'm going to write the class name as employee. So let's try to take one package as 𝐶.Edureka, and let's finish it off. Now I want this employee class should be a 𝐶𝐿 class. So I'm going to write one employee ID. Let's write one employee name, and let's also try to write some employee salary. So if you want to come up, you can come up with some more data, right? So these are the attributes for my object which I have mentioned in our class, right? And thereafter I need to define constructors, getters, and setters to come up with the POJO structure, right? So let's say right click, source, generate constructor using fields. So this is one constructor along with all the fields. So I'm also going to construct one constructor as in a default one. So let's try to write one default constructor. I got one constructor with all the inputs, and lastly I'm gonna do it as generate getters and setters. Let's select all. So here we are with the getters and setters, and now I'm also gonna write one toString method. So let's generate one toString method. So this is one structure which is representing POJO or model or bean, right? So we call it as a POJO or a model or a bean structure, right? So once I am done with this, what I will do next is that I'll write one client class. So I'm gonna write one class as in client along with the main map, right? So this is my main method. So what is the traditional way as a developer, how I will construct the objects, right? So I will say employee as in a new employee, right? And thereafter I'll say e dot set of eid as 101, e dot set of employee name as in, let's say, John Watson, and finally I will set a salary, let's say 30,000, right? So this is the traditional way how you will construct an object. So other than that, all right, so I think I did something wrong. All right, so I have taken the salary as in string. So guys, let me change it to the integer part. Just a moment. So here we are, done. Now I will just say CISO and I will try to print the E. So what I will get as in response, I will be getting the response as in the details of the employee. Now this is my traditional way how we construct the objects in Java. Let's try to follow the Spring framework and let's see how we can come up with inversion of control, right? So I'm gonna write something known as inversion of control, right? So IOC as in Spring framework. So let's see how we can do that. To do that, I'll follow certain steps. The step number one will be to add jar files for core. I'll just say for Spring core, right? So let's add jar files for Spring core, right? Number two, configure Java object in an XML file, right? And number three, use Spring container, Spring IOC container. So when we are saying IOC container, for example, Bean Factory or application context to get the objects constructed by them. So we now need to follow these three simple steps to perform the first fundamental, that's like inversion of control. We add the jar files for Spring core and thereafter we're going to configure the Java objects in an XML file, and finally we'll use the Spring IOC container, for example Bean Factory or application context, so that we can get the objects constructed by the Spring container itself, right? So let's see how we can do that. So step number one, I'm going to configure my project with the build path with the Spring core jar file. So I'm going to say build path, configure the build path. And in my build path configuration, I'm going to add the external jars under the libraries. So here we are with the Spring jar. So I already have my core jars available over here, right? So you can download it over the web. So I'm just going to link these jar files with my project structure and let's say apply and OK. So here we are with the Spring core jar files available in my project, right? So once I'm done with this, so the next part is to come up with one XML configuration file. So let me take up to that. So just a moment. So I'll just copy one of the employee bean.xml file. So I have this XML file and I'm going to copy it in my src directory. If you will see, I'm not copying it to my package. I'm copying it into the src directory out here, right? So once we are done with the copying of this XML file, let's try to open and see the structure of this XML file now. So the structure of the XML file says that it's basically one root tag known as beans with the tag known as beans and the property. So what is this bean ID all about? So ID can be any name of your choice. For example, I'm going to say this is emp1 and the class over here goes like co.edureka.employee. The property is the attribute names available in your POJO structure, EID, ename and eSalary, right? So I got EID. So for my EID, the value goes like 102, right? And similarly, I got ename and eSalary. It's in lowercase, I think. Let me just cross check. Right. So it's all in lowercase. So ename goes like Jenny and eSalary goes like, let's say 50,000. So this is my one of the beans. So I can declare as many as object configurations over here, right? So let's try to come up with some M2, and let's say this is 103. This is Jack with 46, right? So these are the two configurations which I have done in the XML file. So the first thing was to link the jar file. Second thing was to configure the concept of my objects as in key value pairs. So key are attribute names and the value is the exact value which the object will hold for its attribute. So this is the state of an object now, right over here. Now what is next? So the next part is to use the Spring container in my client class. So use the Spring IOC container. So I'm gonna use the application context out here. Right, so let's see how we can use the application context. So you say application context, if you can see over here. So application context as in a new class path XML application context, and you mention over here employee bean.xml. So guys, this name of the file can be any name of your choice, right? You are free to use any name, but make sure that this employee bean.xml file is available under the src directory, right? So here we got employee bean.xml file, right? And that too within the application context. So now I will say employee even as in context dot get the bean you mention as emp1. So what we are doing, we are using the API known as getBean. So this emp1 we gave it in our XML configuration, right? So over here I'll just downcast it as in employee because it's gonna return me the object, right? So we need to downcast. Or the other way of using the same guy is like you say emp2 as in context dot get the b emp2 and you just mention the class over here like this. And now let's say CISO E1 and CISO of E2, right? So here I'm just gonna put a delimiter Spring IOC in action, right? So this is one delimiter. Let's run the code and see the output. So guys, now we can see the traditional way of retrieving the objects was you construct the objects, you set the data, right? And the Spring framework says that you don't create the objects, you use the objects in your program. And now what is the beauty about this XML file coming into over here? So many times we'll be confused, right? So why we are doing all these stupid stuff, right? The reason is that XML over here can be changed anytime, right? And you need not to worry about changing the source code. So it's not the kind of a source code, right? So XML file is not a source code which will be compiled into some binary and then binary will be processed by JVM. So JVM is processing the Java files as in the bytecodes. So this XML file is not a part of your source, right? So it's gonna be modified at any time, whenever and as required by us, right? So here the configuration goes in the XML file. So the real implementation of the same inversion of control can be seen in the Android, right? So let me run down with one example over here. So where this inversion of control fits into. So let's see that part. So how the Spring framework is related to the Android, let's try to come up and understand this part. So it's a very beautiful concept, the inversion of control which we have demonstrated over here, right? So let me try to open any of the applications over here. All right, so let the system gets loaded for us. So even though it's exactly out of our context, but it's just for the reference purpose, right? So we'll now see that there is something known as these layout files, which are all the XML files. If you can see over here, so these are different XML files, and in these XML files I can see that we got some configurations done out here, right? So these are the properties now. So what is the menu? It's a drawer menu, right? So what is the width? What is the height? So for every Android UI part, so we got these configurations available in the XML file, right? So anytime user can actually come down and change the XML file structure, so the code will not be affected. So what Android will do, Android will read these XML files and it's gonna construct the Java objects. It's inversion of control which is available. So in my code, if you can see over here, right? So the UI is exactly dependent, if you can see the same XML file structures, right? And we are trying to say find view by ID. So let's try to understand this. So here you can see the toolbar coming up, right? So as in some toolbar, and here we are trying to say find view by ID as in toolbar. So it's a very much similar story, as in we are trying to say context.getBean, right? So the API standards are different. So guys, this is what we got as in Spring IOC, right? And the introduction to the Spring framework. So thank you very much. I hope you have enjoyed the session. So for more information, you can always visit our website. Once again, thank you very much. Bye-bye.